Our agenda for today is to learn about the basics of waves. We're going to start off by reviewing the parts of a wave. This you've learned in the Slinky lab, but we'll just review them here. Each of these parts of a wave has an associated symbol with it, and these parts of the wave are measured quantities, and we'll discuss what units they are measured in. Then we'll use these symbols in several equations that relate parts of a wave together. And then finally, we will end with a few questions that I will ask you to solve. Okay, so let's get to it. A few definitions. First, the wavelength and amplitude. Wavelength is just what it sounds like. It is the length of a wave, and it's when the wave starts repeating itself again and again. The easiest way to measure wavelength is to go from the top of a wave to the top of the next wave here, so top to top. But it's really, fundamentally, it's when does the waves begin repeating itself. So we can go down here, up here, and as soon as we get here, look, it's going to do the same thing again. So this is the wavelength. Amplitude is how high the wave is, and it's not the height from bottom to top, it's where the wave would be if it were flat. So if there was no wave, this would be flat right along here, and this is actually the correct amplitude. Speed is how fast something is going. Frequency is how many waves go by each second. So in 1 second, you just count them up like that little girl above me is doing. So if you count 5 waves going by every second, we say the frequency is 5. We'll talk about the units later. The period is how much time it takes for a wave to go by. Alternatively, it's how much time it takes to make a wave. Those are the same exact thing. Finally, the medium of a wave is what is actually waving, what is moving either up and down or left or right. So in this picture, the medium is the water, because it is the water that is sloshing, that's moving around, sloshing around in this case. One of the big misconceptions that a lot of students have is that the medium is the cause of the wave. So perhaps this wave was caused by a storm offshore. Well, maybe it is, maybe it isn't. Who cares? The medium is the water that it's traveling through. It doesn't matter what the cause of the wave is. All right, let's get to symbols and units. Here are the 4 quantities that have symbols: wavelength, speed, period, and frequency. And here are all of your symbols. We'll start off with the worst. Wavelength has this weird upside down Y. It's called lambda. Okay. Speed has a symbol of V. You might think, wait, where does V come in here? Think V for velocity, which is a quantity that is highly related to speed. Frequency has symbol F. Yay! F starts frequency, that makes sense. And period is a capital T. Now, period is the time that it takes to make a wave. So, hey, time is T, and big T lets us know that this is an important number. Now, units. Wavelength is the length of a wave, so we measured in meters. You could measure it in centimeters or inches, but we'd prefer meters here, but any distance measurement is good. Speed, we usually like using meters per second. Alternatives would be, say, miles per hour or kilometers per hour. Basically, any distance divided by time is a speed, but we'll tend to use meters per second. Frequency, this is number of waves per second. Waves is not like a measurable thing, it's just a number. So the unit is actually 1 divided by second, blah per second. Now, nobody calls it 1 over second. We use the word hertz, naming it after a famous physicist who did a lot of work with waves. Now, how are you going to remember that frequency has the unit of hertz? Well, if you forget, it's really going to hertz. Period is the time that it takes to make a wave, and we measure time in seconds. All right, so we have done quite a bit so far. We've reviewed the parts of a wave. We have looked at the symbols and the units associated with these parts. Now we're going to derive some equations. Let's see how period and frequency are related to each other. So I've got a list of periods right here. These are the times that it takes to make a wave, and we're going to see if we can figure out what associated frequency these have. So let's suppose it takes 1 second to make a wave, right? So you're holding a slinky and you go 1 Mississippi and you make a wave. How many waves have you made per second? Well, the answer isn't all that complicated. If it takes you 1 second to make a wave, you've made 1 wave in 1 second. And that, the answer is 1. 1 hertz is our frequency. But now it only takes you half a second to make a wave. So you can wiggle your hand a lot faster now. How many of those waves do you make in a full second? Well, in half a second, you make a single wave, and then the next half second, you make another wave. Full second has passed, you have made 2 waves, so you have waves have a frequency of 2 hertz. Now you get even faster. You wiggle your hand back and forth in a third of a second. So the first third of a second, you make a wave. There's 3/3 of a second. Each one you make a wave, so you're making 3 waves every second, 3 hertz. Now, take a moment and think about what the frequency would be if it took you 1/4 of a second to make a wave and then 1/10 of a second to make a wave. You can pause the video if you'd like. Okay, let's reveal it. For 1/4 of a second, 4 waves per second, 4 hertz, and then 10 hertz. Okay, now let's see if we notice a pattern here. You've probably seen something. Let's put it in an equation. And let's think about how to get from frequency over to period. What do you do to this number to get this number? I think you see all you have to do is put 1 over the frequency, 1 over this number, and you get this number, and that works for everything. So what if we just say that the period equals 1 divided by the frequency? And that is our equation, our first equation. Period, which is symbol T, equals 1 over frequency, which is symbol F. Usually this is written the other way around. If we do a little bit of algebra here, we can actually switch period and frequency. This is legitimate. Go work it out if you don't believe me. So that frequency is now equal to 1 divided by the period. And I've written this out down here. This is the form of the equation that we'll be using most often in this class, but it's equivalent to this one. Another equation that we're going to use is an oldie but a goodie. You've probably learned it already. The definition of speed. Speeds are given in, say, miles per hour, meters per second. It's always a distance divided by time, and that is the equation. Speed equals distance over time. And I'll write that as V equals D over T. V is speed, D is distance, T is time.